In this video, I will work through free response question number 4 from the 2003 Form B AP exam. Number 4 is a no calculator question. A particle moves along the x-axis with a velocity at time t greater than or equal to 0, given by v of t equals -1 plus e to the 1 minus t power. For part A, find the acceleration of the particle at time t equals 3. So we know that acceleration is the derivative of velocity. So let's go ahead and find the acceleration formula by taking the derivative of velocity. So we will write acceleration at t is equal to v prime at t. And let's do it. The derivative of -1 is 0, so that's gone. The derivative of e to the something, technically we're doing the chain rule. So the derivative of e to the something is still going to be e to the something. So I'm going to write e to the 1 minus t power. But then we need to multiply by the derivative of the inner function here. The derivative of 1 minus t is -1. However, I'm going to go ahead and put the -1 in the front. So this is the acceleration equation. If we want the acceleration at time t equals 3, we will just evaluate a at 3. So this will equal -e to the 1 minus 3 power. You could leave it like that, but you would feel a little silly for not doing 1 minus 3. So I'm just going to go ahead and put e to the -2 power, and then I will stop. So that's the answer to part A. Part B is the speed of the particle increasing at time t equals 3. Give a reason for your answer. Let me hit you with some extra knowledge that you're going to need. If velocity and acceleration both have the same sign, then the speed is increasing. If the velocity and acceleration have opposite signs, then the speed is decreasing. I think of it this way. If velocity and acceleration have the same sign, that means they're working together. So that's why the speed would be increasing. If they have opposite signs, then velocity and acceleration are sort of working against each other, and that's why the speed would be decreasing. We already know that the acceleration at time t equals 3 is negative. E is a constant, a positive number, and having the -2 power just means 1 over e squared. And so this part is a positive number. Having the minus sign in front guarantees that the overall acceleration is a negative value. So the acceleration is negative. Let's find the velocity at time t equals 3 and see if it's also negative or if it's positive. We are given the velocity equation, so let's just evaluate at time t equals 3. V at 3 will equal -1 plus e to the 1 minus 3 power. So that's v at 3 is equal to -1 plus e to the -2 power, which would be the same thing as -1 plus 1 over e squared. So we are asking ourselves whether this value is positive or negative. E is a constant that is approximately 2.72, and we're squaring that. So we have 1 over some number that is definitely bigger than 1. So that means this overall fraction is going to be some decimal that is between 0 and 1. If we add -1 plus some decimal that's between 0 and 1, the overall result will be negative. It's going to be less than 0. So now we see that the velocity is negative and the acceleration is also negative. So therefore, since the velocity and acceleration have the same sign, the speed is increasing. Let's just write up that answer. So we can say the speed of the particle is increasing at time t equals 3 because the velocity and acceleration are both negative. Part C. Find all values of t at which the particle changes direction. Justify your answer. So here's the key. The sign of the velocity indicates the direction in which the particle is moving. So the particle changes direction when the velocity changes signs. Let's start by finding the values of t that cause the velocity to equal 0. Then we'll make a sign chart to see where velocity changes signs. They gave us the formula for velocity, which was -1 plus e to the 1 minus t power. So let's set this equal to 0 and solve. Adding 1 to both sides, we have e to the 1 minus t power is equal to 1. Well, this is interesting. So if you raise something to a power and you're getting 1, the only way that's going to happen is if you raise it to the 0 power. All right? Any constant to the 0 power is going to equal 1. So that means that this exponent must be 0. So we can conclude that 1 minus t must equal 0. Adding t to both sides, we get 1 is equal to t, or in other words, t equals 1. So t equals 1 is the only value where the velocity is equal to 0. Let's do a test value on the left and right and see if the velocity changes signs. So on the left, let's check the velocity at time t equals 0 and see if that's positive or negative. So that would be -1 plus e to the, 1 power, because t is 0, and we don't really need to put the 1. So is this going to be positive or negative? Remember that e is approximately 2.72. So that means this is a positive value. All right, so how about something bigger than 1, like 2? So let's check v at 2 and see if this is positive or negative. So that would be -1 plus e to the 1 minus 2 power. So let's see. So v at 2 is equal to -1. This would be the -1 power. And e to the -1 power is 1 over e, which would definitely be something between 0 and 1. So the net result would be negative. So we can see that the velocity changes signs at the value t equals 1. So that is the time when the particle changes direction. We'd say the particle changes direction at time t equals 1 because the velocity changes from positive to negative. Part D. Find the total distance traveled by the particle over the time interval from 0 to 3. We know that distance traveled is the integral of the velocity function, but you have to be careful. If I wrote it this way, this would mean the net distance traveled, not the total distance traveled. So we need to do the absolute value of velocity. For example, imagine a particle at 0. It travels 3 units to the right. Because it is to the right, that is a positive 3 units. But then it travels 2 units to the left. Because it is to the left, that is -2 units. That is a net distance or displacement of positive 1 units. That's what we are calculating when we take the integral of velocity without the absolute value. We're finding the net distance. We're finding the displacement. But if we wanted the total distance traveled by the particle, we'd want to count all 5 units, 3 to the right, 2 to the left, total of 5. that's where the absolute value comes in, because if we can take the absolute value of the negative portion, then we will end up with a positive 3 and positive 2 for a total of 5. So hopefully now you're convinced why we need the absolute value. The key about absolute value is that we are making sure that velocity is always positive. Looking back at our work from part C, we remember that velocity is positive to the left of t equals 1. So from 0 to 1, the absolute value is not really doing anything. It's already positive. So we can just leave velocity alone and use the original equation from 0 to 1. We need to integrate from 0 to 3. So far, we've got the integral from 0 to 1, and we can leave the velocity alone because it's already positive. The absolute value is not doing anything. But now we must continue and integrate from 1 to 3. We're integrating the rest of the way. So what's going on? Looking back at part C again, after t equals 1, velocity is negative. So that means in order for velocity to be positive, we will have to do the opposite of our velocity function from 1 to 3. So between 1 and 3, velocity is negative. But if I go like this, bam, now it's positive. At the beginning of the problem, we were given the velocity formula. V at t is negative 1 plus e to the 1 minus t power. So from 0 to 1, we can just substitute in the formula as is. So the integral from 0 to 1 of negative 1 plus e to the 1 minus t power dt. But from 1 to 3, we need to do the opposite of this function. So I'm just multiplying everything by negative 1. So I'm going to have positive 1 and minus e to the 1 minus t power dt. So now I'm integrating this term by term. The integral of negative 1 is going to be negative t. I'm doing a u substitution in my head, so I'm getting negative e to the 1 minus t power. I will show you what I did off to the side, but let me go ahead and put the limits of integration from 0 to 1. Here's the mental u substitution that I just did, just in case you need to see it. Let u equal the 1 minus t, then u prime is going to equal negative 1. So this will be the integral of e to the u, and instead of dt, we will write du, but we will divide by u prime. So we're dividing by negative 1, which would be the same as multiplying by negative 1. The derivative of e to the u power is still e to the u power. We don't need the plus c because it is actually a definite integral. So that part doesn't change, and we just bring down the negative 1. And then u was the 1 minus t, so we have negative e to the 1 minus t power. So really, nothing changed except for we got a negative sign in the front. So that's what happened here. We took the integral of e to the 1 minus t power, and nothing really changed except for that's where the negative sign came from. So when it comes to this mental u substitution, if you look at the thing that you are wanting to make the u, if the derivative is just negative 1, you know it's just going to end up being a negative in the front. All right, it's coming up again over here. So integrating from 1 to 3, the integral of 1 is going to be t. And then again, when we take the integral of e to the 1 minus t power, the derivative in this area is negative 1. So that's just going to end up in the front, which will cause this negative to turn into a positive. So we will end up with positive e to the 1 minus t power. And this is from 1 to 3. So evaluating from 0 to 1, I do the value at 1 minus the value at 0. Similarly, to evaluate from 1 to 3, I do the value at 3 minus the value at 1. And guess what? Because this is a free response question, we can leave our answer just like this, as ugly as it is. And maybe you should leave your answer like this, because if you make a mistake as you simplify, you will lose points. So it's safer actually to stop here. I'm going to keep going just because it's more satisfying, but feel free to leave your answer like this. So we will have -1. E to the 0 power is 1. So we have -1 minus 1. And then this 0 is gone. And this will just be -e to the 1 power, which is just -e. So then over here, we have 3 plus e to the -2 power minus 1 plus e to the 0 power. So e to the 0 power is 1. So -1 minus 1 is -2, minus -e is positive e. 1 plus 1 is 2, so that's where this -2 came from. Now combining like terms, if we do -2 plus 3 minus 2, that's just going to be -1. So we have -1 plus e to the -2 power. And that's about as simplified as we could make it. So that's it.